This is Algebra 2B, Lesson 1 for probability. So, probability is the study of chance or likelihood. And normally we represent our probabilities either as fractions or decimals or percents. Now, the really common, easy thing that people like to talk about is flipping a coin, heads and tails, right? So like the probability of getting a head is 1 out of 2 or 50% or 0.5. That's our fraction, our decimal, and our percent. Because there's one possible outcome, heads, out of 2 possible outcomes, heads and tails. So the probability of an event is the number of ways that you can get that event out of the total possible outcomes. Now, probability is always going to be on a scale from 0 to 1. And if we want to talk about that as a percent, you can also say 100% or just 1, right? Because the middle here, 50% or 0.5, means like heads and tails. 0 means it's never going to happen. 50% or 0.5 means it's equally likely to happen or not happen. 1 means for sure it's certainly going to happen. Okay? But you're never going to have like 1.8. You're never going to have 12. You're going to have 17. It's going to be 17% or 0.17. It's going to be a decimal or a fraction to be a probability between 0 and 100%, between 0 and 1. Okay? Sample space is the fancy way to say all possible outcomes. So when we were talking about flipping a coin, that was heads or tails. If we're talking about rolling a standard die, it would be 1, 2, 3, 4, 5, 6, right? Die, singular for dice. People always get a little scared by that one. So sample space is just all the possibilities. On a coin, that's heads or tails. Rolling a die, that's 1, 2, 3, 4, 5, 6. Complement is the something not happening. So if I'm talking about the complement of flipping a heads, would be tails. If I'm talking about the complement of rolling a 1, that would be not rolling a 1. So rolling a 2 or 3 or 4 or 5 or 6, anything else, okay? And we're going to use a little kind of like apostrophe. If I could talk about the probability of heads, its complement would be tails. Okay? The complement of rolling a 1 on a standard die would be the probability of rolling a 2, a 3, a 4, a 5, a 6. Okay? So it's everything else. Now, if you add up the probability of something and its complement, that's always going to equal 1 whole or 100%, right? So complement probability of heads and its complement tails, 50% and 50%, that's 1 whole. Complement of rolling a 1 is 1 out of 6. Rolling a 2, 3, 4, 5, 6, that's 5 out of 6. So if we add those up, again, that is 1. So with some basic notes out of the way, let's try a couple practice problems. Example A says the spinner shown has 10 equal-sized sectors. Determine each probability. So probability of spinning a 5, we're going to put the number of ways you can get a 5 out of the total possible outcomes. So if I look at the spinner and say, how many 5s do I have? There is only 1 sector that has a 5 out of the 10 equal-sized sectors. It did tell us 10, but we could also count them if we needed to see that there are 10 altogether. Okay? The probability of getting an odd. Okay, I'm going to look at my odds. So 5's odd. Even, odd, even, odd, even, odd, odd, even, even. So I got 1, 2, 3, 4, 5. 5 odds out of 10 equal-sized sectors. Now, if you want to, you can reduce your fractions. You can even switch them to decimals. You can even switch them to percentages. All those answers are correct. I'm not going to be particular about reduced fractions or decimals or percents. So as long as your answer is correct in any form, it's good for me. Letter C, what is the probability of getting something greater than 4? So greater than 4. 6 is greater than 4. 4 is equal to 4, but not greater than 4, so we're not going to count 4. And 5 is greater than 4. Nothing else is greater than 4. So 2 of my outcomes out of the 10 possibilities were greater than 4. I can reduce that if I want to. I can get a decimal if I want to. I can get a percent if I want to. All of those are correct answers. And the last one says perfect square. So perfect square, we're talking about our square numbers. Like if we do 1 times 1, that's 1. Or if we do 2 times 2, that's 4. Or if we do 3 times 3, that's 9. Now I could keep going on this list, but we can tell by our sample space that the highest value we have is 6, so I really don't need to keep going. So I'm just counting up the 1s and the 4s. So I have a 1 and a 4 and a 1 and a 4. So that is 1, 2, 3, 4 values that I underlined. 4 perfect squares out of our 10 sectors. Again, we can reduce our fraction if we want to. We can go to percent or decimal if we want to. Or just stick with that first fraction, 4 out of 10. You do not need to reduce them. And we are good to go. Make them look more like a 0, not a 6. Okay? Let's try our next example. Example B, a pair of fair dice are rolled and then summed. So I'm going to roll 2 dice, and then I'm going to add them together. What are the things I could possibly get? Well, the lowest thing I could get, if I'm rolling 2 dice and then add them together, is a 2, because I could roll a 1 and a 1, add them together, that would be a 2. Then I could also get a 3, a 4, a 5, a 6, and I'm going to keep going. The highest thing I could get would be rolling a 6 plus 6. 6 plus 6 is 12, so it looks like anything from 2 to 12, whole numbers, that are my possible outcomes, okay? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I want to look at the sample space, not each of these outcomes is equally likely. There's only one possible way to get a 2. That's a 1 and a 1. But there's lots of ways to get a 7. I could get a 1 and a 6, or a 2 and a 5, or a 3 and a 4. And actually, if the first die is a 3 and the second die is a 4, that's different than the first die being a 4 and the second die being a 3. So all that goes to show that if we want to look at the sample space, we need to look at how likely each of those outcomes are. So I have this table here, and we're going to fill in the values that we would get based on our first die and our second die being rolled and then added together. So like I already said, if I roll on a 1 and 1, that's a 2. If I roll a 2 and a 1, that's a 3. A 3 and a 1, that's a 4. So I'm going to just keep adding these together. 2 and 1 be 3, 4, 5, 6, 7, 8. 4, 5, 6. And last column. So obviously 2 is not a very likely outcome. Neither is 12. The only way to get 12 is 6 plus 6. But 7 shows up a lot because I got 1, 2, 3, 4, 5, 6. 6 possible ways to get a 7. So that is the most likely outcome. Okay, so now that we have the sample space, we can see that there are 36 items in our sample space. So when we're looking at our probabilities, we are going to have our fractions be out of 36 because of the 36 outcomes. Okay? Even though there's only 2 through 12 outcomes, there's 36 possible outcomes in our sample space. So doing some of these probabilities at the bottom. What is the probability of getting an 8? Okay? So I have 1, 2, 3, 4, 5. I have 5 8s in my table out of the 36 items in my sample space. Letter B, what is the probability of getting something less than 5? So less than 5, let's do some colors here so we can keep everything organized. Less than 5 would be 2 and 3 and 4, but less than 5 does not include 5, so it looks like those are all of my possible ways to get something less than 5. That's 1, 2, 3, 4, 5, 6. 6 ways to get something less than 5 out of the 36 possibilities in the sample space. I am going to reduce this fraction to 1 out of 6. You can leave it 6 out of 36. I just wanted to show that one also. Letter C, what is the probability of getting a multiple of 3? Multiples of 3 would be like 3 times 1, 3 times 2, 3 times 3, 3 times 4. So our multiples of 3, in the context of our dice sums, you could get a 3, a 6, a 9, a 12. I'm not going to keep going up to 15 because that's outside of our sample space. So I'm looking for all the 3s, 6s, 9s, and 12s, okay? So we'll go, here's a 3, here's a 3. We have 6s down this diagonal. We have 9s down this diagonal. And then we have a 12. So I'm going to count up all my purple dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 multiples of 3 out of the 36 elements in our sample space. Now, if you wanted to, you can reduce that fraction. And if you wanted to, you could go decimal or percent, but I'm going to stop at the reduced fraction. And the last one says, what is the probability of not getting a 7? So we talked about complements. Complements is the chance that something does not happen. And you can do this one of 2 ways. We could count up all of the not 7s, or knowing that a probability and its complement have to add up to 1 whole, we could count all the 7s and then take away from 1. I'm going to do both just to see that they come out to be the same answer. And let's go green. So all of my not 7s, okay? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. All of my not 7s, 30 out of 36. Conversely, if we had counted up all the 7s, that's 1, 2, 3, 4, 5, 6. And notice that they're going to add up to 1 whole. 30 and 6 makes 36 out of 36, which is 1 whole. So we could have done 1 minus 6 out of 36 to get the same answer, okay? And do we want to reduce this fraction? Sure, why not? 30 and 36 both divide by 6, so that would be 5 out of 6. So you can say 30 out of 36, or 1 minus 6 out of 36, or 5 out of 6 to get 30 out of 36. I think that's it. Good luck on them exercises, and please let me know if you have questions.